Hello everyone, today I'm here to conduct our lab experiment 3. Today we will have two separate experimentation. First of them will be discharge penny at sluice gate and the second one will be force on a sluice gate. We will start with the discharge penny at the sluice gate. The objective of this experiment is to determine the relationship between upstream head and flow rate for water flowing under a sluice gate and to calculate the discharge coefficient and observe flow patterns obtained. Now I'd like to continue with the third part for the discharge beneath sluice gate experiment. If you look at your lab manuals, you will see there is an image provided to us and we have some notations on this image. I will explain them later. Before this explanation, I'd like to show you this equation which is for the flow rate of the water. We have CD, B, YG square root and 2G V0. If you take this CD out from this equation and leave it alone, at the end you'll get this one. In this equation, Q is the flow rate, CD is the discharge coefficient, B is the breadth of weir, YG is this which is here, height of weir opening above bed, and Y0 is the upstream depth of flow which is here. And G, of course, is the gravitational constant. Below these notations, we have two more equations are provided. One of them is for H0, one of them is for H1. H0 is the total head upstream of weir, and H1 is the total head for downstream of the weir. You can see them here in this image. If we look at this equation for the H0, it is equal to Y0 times V0 square divided by 2G, which is basically velocity head. So instead of V0 here, we can write Q, which is discharge, divided by the area of this flow here. The area of the flow is equal to depth of flow and the width of the channel, which is B in this experiment. So instead of V0 square, we can write Q square divided by Y0 times B square. And for downstream head, it is same as well. H1 will be equal to Y1 plus, this time instead of V0, it will be equal to V1 square over 2G. And again, instead of velocity, we are replacing with the discharge divided by area for downstream values, of course. And this is all for this part. For the first part of the measurements, before we start the experimentation, we have to set the YG, which is the distance between the bottom of the sluice gate and this top portion of the water tank, as 2 centimeters. Then I will let water accumulate into this system and water will start rising here. Once it reaches 20 centimeters here, I will adjust the discharge and it will stay constant. Then I will keep changing this distance, which is YG, and take different measurements according to changing YG values. For the second part of the experiment, again we have to set YG 2 centimeters and and let water inside to the system and raise here till 20 centimeters. Once it is done, again we will start playing with this YG distances from here. But this time, different from the previous experiment, we will keep Y0 constant, so therefore with changing YG values, I will change discharge values from there as well, from a valve, and take measurements accordingly. Now I'd like to continue with the second experiment of today's.
which is force on a sluice gate. Objective of this experiment is to determine the relationship between upstream head and the thrust on a sluice gate for water flowing under a sluice gate.
Now I want to continue with the theory for the force on a sluice gate experiment. In your manual, you will see there is this image. If you look at this image, we have a hydrostatic pressure distribution here on the upstream. We have non-hydrostatic pressure and hydrostatic pressure distribution on the downstream. We have Y0, we have YG, and we have Y1 again. And just below this image, we are provided a formula for Fg. It is a very long formula, but I will explain what these notations are. And on the below this Fg formula, we are given another formula for Fh, which is the gate thrust for a hydrostatic pressure distribution. Again, we have some notations here. If we look at the first equation, we have rho g, y1, y0, we have rho, we have q, b, and that's it. And in the second equation, we have again rho g, y0, and in addition to this equation, we have yg. I actually explained some of them in the first part of this experiment, which was the discharge beneath sluice gate. However, I want to go over them anyways. So Fg is the resultant gate thrust, and Fh is the resultant hydrostatic thrust. Q is the discharge, and rho is the density of the fluid. G again is the gravitational acceleration. Again, B is the width of the gate. Yg is this distance between the sluice gate and the bottom of the channel. Y0 is the upstream depth, and Y1 is the downstream depth. And that will be all for the theory part.
Like we did in the first experiment, here again we have to take two different types of measurements. In the first one, we will keep discharge constant, and in the second one, we will keep the Y0 constant, which we did in the last time as well. Here, again, before we start the experiment, we have to set Yg again as 2 centimeters. And again, we will let water inside to the system and raise to 20 centimeters. And since discharge is constant, I will changing the Yg values, and we will take our Yg, Y0 and Y1 values accordingly. And for the second part, we will keep Y0 constant. This time I will again change the discharge from the wall over there, and I will read measurements for Yg, Y1 and Q values. To start the experiment, from this button I am turning on the system. As you can see from there, water is started to fill this water tank. This Yg is already set to 2 centimeters. Right now I'm observing the rising of water, and when it comes closer to 20 centimeters here, we can read the values from this ruler tape. I will play with the discharge and let it stay there. Now it's slowly increasing. Okay, now it hit the 20 centimeters, and as you see, it stays there, it doesn't move. So, by changing this YG values from here, I will take different types of measurements for the first part. Once we are done with that, I will go there, change the discharge, and this time for each measurement, I will change both YG and discharge values and keep taking the measurements like that. At the end of the measurements, we have to take another measurement for discharge. To do that, from here, I will close this gap with this ball so that water level will start increase in this water tank, and we can read the values from the scale. When I close this ball, drop this ball to close the water, this gap. As you see, water level is starting increasing, and with that recording the time, we can start the discharge.